Hello students, let's start the next question now. The question reads, an air wedge is formed between two optically plane glass plates. When viewed in mercury green light of wavelength 546 nanometer, 12 fringes are seen in a space of 4 millimeters. If the length of each plate is 30 millimeters, calculate the thickness of the space. Now let's solve this. To understand the complete derivation of the formulas, you can go into the link given below. So let's start writing the given first. What it says is, an air wedge is formed between two optically plane glass plates when viewed in mercury green of wavelength. So wavelength is given, that is 546 nanometers, where I can write it as 546 into 10 to the power of minus 9 meters. And how many fringes are formed in what length? 12 fringes are formed in a space of 4 millimeters. Right? There are 12 fringes in a space of 4 millimeters. So how can I write that? 12 fringes in 4 millimeters. So what about the fringe width? One fringe occupies a space of 4 millimeters divided by 12. Right? So that becomes 0.333 into 10 to the power of minus 3 meters. So that's the fringe width, where this you can call as beta. Next, if the length of each plate is 30 millimeters, let's represent that using x equals 30 millimeters, or you can write it as 3 in 10 to the power of minus 2 meters. What are we supposed to find out? We are supposed to find out the thickness of the. Now, before going further, let me explain a bit of theory here. This is simple trigonometry, where you have an angle theta and the opposite side spans t meters, whereas the adjacent side is x centimeters or x units. Let's say this is the nth fringe. Let's say this is nth fringe. Okay. Let's say this is n plus 1th fringe. So the distance between nth fringe and n plus 1 fringe is itself is called as fringe width, right? That is beta. Now the angle is theta. From simple trigonometry, what can we write is tan theta is equal to rise over run, or t divided by x. Also, the condition for a good interference pattern is x theta equals n lambda divided by 2 for the nth fringe. For n plus 1th fringe, it has to span a distance of x plus beta, right? So x plus beta subtends an angle of theta again, and the fringe is n plus 1th fringe, and the condition is n plus 1 into lambda divided by 2. Now, take this as equation 1, take this as equation 2, subtract them. Once you subtract equation 1 from equation 2, we get x plus beta into theta minus x theta becomes n plus 1 lambda by 2 minus n lambda by 2. Beta theta equals lambda divided by 2. Rearranging the terms, we get theta equals lambda divided by 2 beta. Now, keep this as equation 3. Look here, if theta is very, very small, tan theta, sin theta and theta, all of them are same, right? So you can write this as theta is equal to t divided by x. There are two equations now, theta equals t by x as well as theta equals lambda divided by 2 beta. Let's combine those and form the final formula as t by x equals lambda divided by 2 beta. Or I can say t is equal to x lambda divided by 2 beta. Now let's substitute the values. X is 3 into 10 to the power of minus 2. Lambda value is 546 into 10 to the power of minus 9. And beta is 0.33 into 10 to the power of minus 3. If we simplify that, the value of t would be 2.459 into 10 to the power of minus 5 meters. So this is the thickness of the air wedge, and make sure students that you have to write the answer along with the